Today I'm one of the speakers next to moderating the JUG, and together with George, I would like to talk today about AdoptOpenJDK, as already said, and OpenJDK, and how Java can be made free again based on those communities. And there are communities. I think that works fine. Okay, so before we start, let's have a short introduction of George and me. So yeah, I'm Hendrik. I live in Dortmund. I'm the founder of the Java user group in Dortmund. I work at a company called Karakun, where I'm the co-founder of the company, and we have an office in Dortmund too. Our main office is in Basel in Switzerland. And yeah, I do, since several years, a lot of Java-related things at work and even from time to time in my free time. I did moderating the Java user group Dortmund, or I already worked as part of expert groups in JSR. I was part of the Java Bean validation JSR, for example, and helped to define the specification. I did a lot of Java-related talks, tutorials, workshops around the world at conferences. Based on this, I've become a Java champion and a Java 1 rockstar. And what is maybe most important for today is that since last year, I'm quite happy to be part of the AdoptOpenJDK technical steering committee. And together with George and some other nice people, I'm trying to move Java as an open language forward. Okay, George.
Cool. Thanks, Hendrik. So unfortunately, and I always say, unfortunately, my credentials don't come in quite as well as Hendrik's. I'm a Java program manager at Microsoft. I co-founded the AdoptOpenJDK project and subsequently sit as the chairman on the technical steering committee. Alongside Hendrik and others, as you already mentioned. I also like playing in a few other open source projects. So I'm a core collaborator at the Node.js Foundation, and I'm reasonably heavily involved in the OpenJS Foundation, the Foundation Bootstrap team, where we work on pulling JavaScript and Node.js together more closely. So to kind of dive straight in, what we're going to cover today, we're going to do some terminology. This is always quite an important slide because there's 3 different terms that we often refer to in this deck. And they're very similar, but there are subtle differences. So I want to clear those up. We're then going to look at the OpenJDK workflow, where Hendrik's got some very nice slides that we can look at that visualize it. We're going to cover vendor distribution and the differences of each vendor. And then we're going to dive straight into AdoptOpenJDK, talk about the history behind the project, talk about the move to the Eclipse Foundation. We're going to cover some build and test, and we're going to look at the roadmap going forwards. So let's dive into the terminology deck. Here we go. So as I mentioned earlier, 3 terms here: OpenJDK, OpenJDK Binary, and OpenJDK Provider. Now, there's a very subtle difference between each of them. OpenJDK is basically a code-only project. It is the open source reference implementation of the Java SE Standard Edition Java standard, basically. There are no binaries that you can get from OpenJDK per se. It is just the code. If you want to download Java or OpenJDK and run it on your machine, you are looking for an OpenJDK binary, which is a JDK built directly from the OpenJDK source code. So OpenJDK is not a binary. It's not something you can download. It is instead just the reference implementation. And then finally, there's an OpenJDK provider. And so rather than building your own binary directly from source code, I would strongly recommend, go to a vendor who provides one for you that runs a whole lot of tests on it, ensures it's of a good quality. And so that's what a provider is. And I think Hendrik's going to cover later on the differences between each provider. So I think I'm going to hand straight back over to Hendrik to talk about the release train.
Okay, cool. So yeah, I think most of you have already seen a slide similar to this one within the last 2 years, because this is the new release train of Java. To be true, on this slide, we see the new release train of the Oracle JDK, which is a little bit more specific than the general Java release train. So in general, we can say that starting with Java 9 in 2018, it was defined that normally Java versions, so major releases of Java, will only stay for half a year, for 6 months. Like we can see here on the slide for Java 9, Java 10, Java 12, Java 13, 14, and so on. Some of these releases will be defined as LTS releases, as long-term support releases. One of these is Java 11, as we can see here on the slide, where the graph for Java 11 is much longer than only 6 months. The next one will be Java 17, so that all 3 years there will be long-term support release for Java. Based on the colors that we can see here is that we have some problems, because while Java 8, or let's start earlier, let's start with Java 6 and Java 7. What have you done as maybe a Windows or Mac user? You just went to Oracle, earlier to Sun, to the website, downloaded a JIE or a JDK, installed it in your machine, and done, right? Because Java was quite easy to download. You only needed to check one checkbox, and then you were able to use it for free. And this has changed, especially for the Oracle JDK, because as you can see here on the slide, what happened is that around 2018 to 2019, Oracle has changed its license for the Oracle JDK, which means then starting with Java 11, you are not allowed to use the Oracle JDK anymore for free in production. You can still download the Oracle JDK, that is fine. You can install it on your machine, you can play with it, you can learn to program Java with it, absolutely fine, you can do this for free, but it's forbidden to use it in production. And the same is not only for Java 11, or this not only is defined for Java 11 plus, but for Java 8 too, with update 200, I don't know, something that was released in April 2019. The license of Java 8 from the Oracle JDK has changed too. And based on this, you are not allowed to use Java 8 anymore in production without having a support contract with Oracle, because for sure that is what Oracle wants, right? They want that you pay support for Java, and based on this, you can use it in production. But even the non-LTS releases like Java 12 or Java 13 are not able to use for the first 6 months for free when using the Oracle JDK. We will see later. Maybe first of all, this seems horrible, and some people who are not informed on the Open JDK and on different Java vendors might now get shocked, but we will see later that it's not that bad as it's shown on this slide. To have a better understanding what exactly happens here and how this LTS releases were maintained and so on, we need to have a look at the Open JDK and the workflows of the Open JDK. So on the next slide, we can see, oh no, before we go to the Open JDK, we should have a look at the current situation of Java binaries. So as said, for Java 6, Java 8, it was easy. You went to Oracle and downloaded a JDK or a JIE. Today, it's more difficult, because do you go to Oracle, as we've seen, that might be not so good if you don't have a contract with Oracle. Do you go to Amazon and download Corretto? Do you go to Azure and download Zulu, Liberica at Bellsoft? Do you use any Linux distribution? So maybe if you have an Ubuntu installed, you can use apt-get to download Java, right? This is called then OpenJDK. So we've already learned from George that the OpenJDK is not a binary, but the repository or the group where the sources of Java are provided. So what do I download at all when downloading OpenJDK on a Linux machine? So this is quite complex, and yeah, a lot of people don't have answers on this one. And at the beginning, it was totally confusing for all people. Happily, there were some communities, like for example the Java champions, who created some documents and FAQs for this topic to help you to get out of this, maybe let's call it JDK jungle. From all JDKs or Java distributions that are shown on this page, all without one are vendor-based, which means that they are all provided by a company that creates this distribution because maybe they want to sell support options, they want to make money with it. Since Java per default is open source as defined in the OpenJDK, that is maybe not the perfect thing for a programming language, right? That should be learned in college, in school, should be used by startups and so on. And here, one solution that is not vendor-based is the one we want to have a look at today, which is AdoptOpenJDK. And later, George will give an introduction what AdoptOpenJDK is, and we will show how it works internally and how we can provide, spoiler, free Java versions with LTS support. But to understand the general workflows and how others works, let's have a look at the OpenJDK and the workflows of the OpenJDK. So what we are seeing here, we prepared, perfect, thank you. We prepared some questionnaires where I totally forget. So
sorry, I just thought it fits well here. So
yeah, absolutely. So before we continue and have a look at the OpenJDK workflow, so we already mentioned AdoptOpenJDK several times. So I think it's a quite good question to check who's using AdoptOpenJDK in the audience.
So I can see votes coming in.
This is quite exciting.
Okay, so can I share this now? So it's like 71% says they're already using AdoptOpenJDK and 29 aren't.
That's perfect. Very good. Thank you. That's good. Okay, and now let's have a, before we go to that topic, let's have a look where AdoptOpenJDK is based, which is the OpenJDK. So let's have a look at the OpenJDK workflows. So the next part is simplified as much as possible. The workflows and everything in the OpenJDK is hard and complex, and you don't want to do that. What I've tried here is to reduce as much complexity as possible to show the general workflow. So what you see here is not one-to-one how it works. It's an abstraction to understand how the workflows in AdoptOpenJDK work. What we see here in the bottom is like the master of the AdoptOpenJDK source, where Java, the AdoptOpenJDK, is coded, developed. So what happens here is people just commit new features in Java. We see two different kinds of features that are shown by the red or the green color. So all green features or commits, however, are new features that are added to Java, and all red commits are security fixes. Maybe someone finds a vulnerability in the OpenJDK, and then based on this, a security fix is created, and put into the OpenJDK. So what we can see here, since we want to have releases from the OpenJDK, we have a release branch, which is the release branch in this example of Java 8. And as all of you know, once Java 8 is out, all the sub-releases of Java 8, we normally do not get any new features, but what we get are CPUs, which stands for critical patch updates, which means like security updates. Yeah, it's more or less like this. So this contains security updates, fixing critical bugs, and so on. And this is done by merging all the security fixes from the master into the version branch. All the new features that are developed in the master will never be merged into this version branch. But by doing so, we can, I don't know, at the moment, it's like all 3 months, a new release will be done. So all 3 months, a new release of Java 8 will be done that contains all important security fixes and bug fixes that have been found in Java. And this is quite important to have them and have an updated Java 8 version out. If you want new features, you need a new Java version. But if you just want to have a stable version with all the fixes, you can use builds that are based on this Java 8 branch. Okay, as we all know from Java 6, Java 7, and so on, from time to time, such branch just, is not supported anymore. The version stops, there won't be any new updates for example, Java 4 or 5 or 6, or I think 7 don't have any update, 7 don't have any updates too. And this just happened based on that no additional fixes will be merged into this branch anymore. But this is a moment where some companies step in and provide commercial LTS for such version. So if we take, for example, Java 8, there are several companies who provide LTS support for Java 8. Happily, we now have today some companies that provide it for free so that you can download free Java 8 versions, for example, that contains all the fixes. But 2 years ago, there were a lot of discussions if in future we will have any company who does this at all, because the first companies that committed to providing LTS support for Java 8 and so on only provided commercial support. And this is normally done by cloning, copying, merging, forking, however you will call it, the Java 8 branch into a closed repository. So a company like Oracle or any other companies, this is done, for example, by Azure and some other companies too, start to work in a closed source branch on the last state of the Java 8 branch and provide LTS support based on this branch. So next to this, what normally happens, a new Java version evolves. In this case, Java 9, right? So on the next slide, we see that Java 9 as a branch will be created out of the master branch. And as for Java 8, security fixes will be merged or backported into the Java 9 branch. So whenever I say merge, it sounds like, okay, I click a button and the security fix from the master is into 9. You know that merging sometimes can be hard, but now assume you need to merge something in the OpenJDK that maybe is fixed by using stream and lambdas, but you need to backport it into Java 7, where you don't have streams or lambdas. So such fixes often really need to re-implement the security fix because the actual fix use language features or things like that in the LTS branches are not available at all. So based on this work can be hard, and this can end in different implementations, because if 2 people should implement the same, at the end you will have 2 solutions, right? So we're now having a look at the vendor A, vendor B, and vendor C, which is in this case Oracle branch. You can assume that after some of the security fixes, they are not 100% the same anymore. It can even be worse, because when a company provides commercial support for money, they can even get more money if they provide working on the branch based on time and material, for example, and fix specific things for a customer if the customer pay for it. This means maybe in the closed source branch of vendor I, next to the security fixes, vendor A implements some new features because the customer wants that. And this would end in totally different JDKs. And since Java is a standard, we have the Open JDK, we have the language, and whenever you run an application, you want this application just works, and you don't want to take care about, okay, is it now on this one time, on that one time, okay, this is working here, on this one time, the string has this additional method that I cannot use here. That would be totally horrible, right? But some time ago, the community was afraid that it could go into this direction because you need LTS updates. You cannot just switch all 6 months to a new version. But a lot of companies just cannot pay the money or are not willing to pay the money for LTS, which ends in two solutions. One solution is that, yeah, you don't use Java anymore. The other solution is you use old versions without security fixes. I'm quite happy that this is not the reality today because there were some companies that were against this idea and started again to contribute to Java in the open. One company is Red Hat, and what Red Hat has been done and still is doing can be seen on the next slide, because they provide LTS releases or versions for Java 8 and Java 11, but instead of working in their own private repository, they do all the fixes and merges directly in the Open JDK, which means that in the Open JDK, we have at the moment for Java 8 and for Java 11, Java versions that still will be maintained and where all the security fixes will still be committed in the open. And this just means that if you want, you can check out the Java 8 or Java 11 branch of Open JDK and just build your own Java that contains all the important security fixes as defined today. You shouldn't do that, as we will see later, because that has some other problems, just simply buying your JDK and use it for mission critical applications. But in theory, you can do it. That's absolutely fine, since some companies like, for example, Red Hat, another company that does such contributions to is Bellsoft. They backport all their fixes into the Open JDK. Those companies allow us to still have long-term support for Java in the open. Okay, those are some basics of the Open JDK, of the work in the Open JDK, how the work in the Open JDK works in general, and how companies provide Open JDK binaries or Java binaries. If we go to the next slide, we can see the result based on this, because when talking about the general Open JDK release train, today we can just say that everything is open source and free, even the LTS versions, which are currently Java 8 and Java 11. As said, the next one will be Java 17. And since there is no 100% guarantee today, you can assume that it will be exactly the same, so that even Java 17 will be developed completely in the open, and even after 6 months, all the contributions about fixes and security in Java 17 will be done in the open. Okay, this means that perfect, we have LTS sources in the Open JDK repositories that can be used to check out and build Java binaries. Does this mean that you can just download your Java binary from any vendor and it will be always the same? Sadly not. Because as we can see on the next slide, even if the base that is coming from the Open JDK will be the same in all binaries, some vendors put some extra stuff on top of the OpenJDK functionality. A good example is Oracle, because they added a lot of stuff in Java versions in the past. Examples are the flight recorder or mission control. So whoever used flight recorder or mission control in Java 8 or earlier might have thought about it like, okay, that's coming from the open source, from the OpenJDK, that's an open source tool, I can easily use it. Yeah, that was one. That was developed closed source by Oracle. Same is it for WebStart. Here it's even worse, as we will see later, because WebStart, so this tool that you can use to start JNLP applications on your desktop, was developed by Oracle as closed source tool, was never part of OpenJDK, and therefore never part of any other Java distribution. So based on the new release train or maybe before we go into this, I mean, I talked a lot about Oracle, but this is not only true for Oracle, right? Others do the same. If we take Azure, for example, Azure has a custom garbage collection that they add on top of the OpenJDK. So when you use Zulu from Azure, this includes a custom garbage collection that you only have when using Azure. And in general, I think this is fine, right? A company can add things on top just to have some additional functionality that is very specific, that maybe let users use your binaries instead of others, because in this specific area, you're just better. It gets problematic when you have something like WebStart, what more or less all Java developers see as a general tool and not as a closed source Oracle tool that has nothing to do with OpenJDK at all. Happily today, even this looks a little better, because based on the new release train, it became harder and harder to maintain all this external tools together with a release train that does updates all 6 months, and have it closed into just one Oracle JDK. And based on this, Oracle and other vendors contributed a lot of this specific things into the OpenJDK. So today, tools like Flight Recorder or, for example, Mission Control are part of the OpenJDK, are open sourced, and can be provided by any other Java vendor. There are still some small things when talking about Java 11 for Oracle that are exclusive in the Oracle JDK. That is, for example, like at Azure, a garbage collection. But the garbage collection that is exclusive in Oracle JDK 11 has already been contributed by Oracle to the OpenJDK. And in Java 12, this is already part of the OpenJDK and therefore part of all the other vendors too. Sadly, maybe you are using it and already noticed it. One tool that is completely missing here is WebStart, because this is one of the problems that happened based on all this migrations and movements with the new release train. WebStart is one of the tools that just stopped, that was discontinued by Oracle and was never open sourced, and created a lot of problems for companies that depend on JNLP and on WebStart. I'm quite happy to say that there is already a solution for WebStart, as we will see later, because Adopt does not only provide Java binaries, it contains some other cool projects too. But maybe first of all, since we talked that much about Adopt, we should do a general introduction of the Adopt project and of the Adopt OpenJDK community. And therefore, I will hand over to George, who just gives an introduction to Adopt OpenJDK.
So if you don't mind, guys, I would just hook up another poll in the meantime.
Sure, then, perfect.
Yeah, okay.
Yeah, please
do another poll.
Do, yeah. Oh, good one. I like that.
So results coming in. Okay, here we go. So we have a majority of people using Java 8 and 11. So basically it's long-term support versions. I guess. Yeah, and we see a few people already using the new versions 11 and so on.
Yeah.
Okay, nice one.
Cool. That looks good. Yeah, Java 11 is growing and growing. That's very good. Okay.
Cool, thanks. So hopefully Hendrik's given everyone a reasonably good sort of overview of OpenJDK and how it's put together and what it consists of. From this point onwards, we're now going to become very, very biased and start talking about AdoptOpenJDK explicitly. So if you came to an Azul talk, you're in the wrong room, unfortunately. So to kind of briefly cover the history behind the project, all the way back in 2003, AdoptOpenJDK was founded. It was actually put together as a Java adoption group, and it was endorsed by Oracle. And its key sort of purpose was to help get Java contributions from individuals and small companies into the OpenJDK source code. For those of you here that haven't tried contributing to OpenJDK, it can be incredibly complicated. There's a lot of hoops that you have to jump through. You've got to sign all sorts of contributor agreements with Oracle. To summarize, it's not necessarily the easiest approach. So that's what AdoptOpenJDK was originally put together for. If we zoom forwards to 2016, IBM created a group called GetOpenJDK, and this was something I was heavily involved in the creation of. And the idea of GetOpenJDK, as Hendrik showed us on a slide earlier on, there are many, many Java vendors out there. And what they are doing is basically diluting the market and producing slightly different binaries with small variations that start to appear. So for example, you might download an Oracle JDK that has a completely different installer to what you may get from Azul. The kind of most notorious story is I think it was the Ubuntu own built OpenJDK binaries were actually being built from the wrong tag. So you're pulling down OpenJDK, let's say Java 8.2U2 build 10, and you're actually getting a 2.2.2 build 10 or something. So there were all sorts of issues, and so the idea was to sort of get rid of all of the dilution in the market and try and tie things back together again. The other kind of sole purpose was to provide Java binaries for as many platforms as we physically could. A lot of vendors sort of provide specific platforms. They might provide Mac, Linux, Windows. One might provide an ARM build. We wanted to try and pull that together and basically give you a complete set of platforms that basically anything you could build OpenJDK on, you'd have it. Going forward early into 2017, IBM donated that entire project to the adoption group. And that really is the point that AdoptOpenJDK, as we all know it today, was founded. Going forward another year, things grew pretty rapidly. We hit our 1 million download mark in about 7.5 months, I believe, which was pretty impressive. Going forward another year, we had 30 million downloads. So again, pretty exponential growth. And the really exciting point here is actually that we had 23 sponsors. And these sponsors were some of the most important JDK users, vendors, whatever they were in the ecosystem. And that was what really allowed us to grow to where we are today. And then finally, coming forward to 2020, we're at 160 million, except we're actually not. I would say we're at 170 million, but I checked this morning, Hendrik.
No.
180 million.
I've checked it. We did the 180 millions today. Because last week when we did the talk, we said, oh, we need to update this. It's 170 now, but I just checked it and we're over 180 since today. So, yeah.
There you go. So stop downloading our binaries because my slide decks are getting out of date. And the really exciting news here is Adopt is going to join the Eclipse Foundation, which we're going to cover on the next slide. So hopefully everyone saw the kind of press release that we put out announcing the move. To very briefly summarize, and we can open up for any questions about this at the end. AdoptOpenJDK is currently backed by the London Java community, which is a user group similar to this. Being a user group, it's a non-profit. It has very small resources and it has zero legal resources, which makes running AdoptOpenJDK incredibly complicated for them, especially when we're dealing with hundreds of thousands of pounds worth of sponsorship money. So we kind of made the decision that it was time to shift the project to a foundation that knew how to handle, some of the largest open source projects in the world, and at scale. And so we took the decision to move to the Eclipse Foundation. The only kind of really interesting thing that's going to happen from day one is the technical steering committee that exists today will be split into a technical and non-technical steering committee. So we're going to have a project management committee, PMC, which will handle all of the technical roadmaps. And we're then going to form a working group, which companies can join. And we're going to basically have a steering committee along with other subcommittees that run there. And that's where all of the non-technical things like marketing, finance, whatever other budgets happen. So it's obviously a pretty exciting point for us. Nothing is going to immediately change. The thing I would like to reiterate is that AdoptOpenJDK is not going to disappear overnight. The binaries that are there will stay there for a very long time. But whatever we produce at Adoptium, which is the new name, unfortunate or not, depending on how you view the name, we will be producing high quality binaries to the exact same standard and the exact same specification as before. Pardon me. So why choose AdoptOpenJDK in the first place? Well, I like to always say that we are business ready binaries, but it's more than that. We are the place to get free binaries by the communities. As Hendrik mentioned earlier, all of the other vendors out there are sort of tied to a specific entity. We are not. We are represented by 25, 26 different companies. And so we have a mutual interest in ensuring that what we produce is of a good standard. It also means that we aren't going to suddenly do an Oracle and change the license overnight and start charging you. We have a very broad, if not the broadest platform coverage out there. As I mentioned, we have a huge number of machines powering all sorts of interesting stuff. The binaries are pretty professionally tested. I won't go into too much detail here. Hendrik's going to cover that one later. We have a mega clear support policy. You can go to our website and read it. In principle, it's a pretty, it doesn't restrict you in any way at all, really. You can bundle our binaries as you would have bundled an Oracle JDK before. You can use them in production if you're making money. You can use them in a cloud environment. You can use them on your developer desktop. We're backed by major vendors in the Java community, and we're already at, and I'll cross this one out again, 180 million downloads. So yes, lots of people are downloading it. I know downloads don't necessarily equate to quality, but if 180 million people are downloading it, it must be pretty good. We're completely open and transparent. Our technical steering committee remains in the open. All of the project is open source other than a very, very small subset of repositories that handle infrastructure secrets. And everything we do happens on GitHub and Slack. So anybody that wants to get involved can go to github.com/AdoptOpenJDK, or they can join our Slack channel and we'll have information on how to join that at the end. Being such a large open source project that has 180 million downloads, there are some issues. As with running any large open source project at scale, things get difficult. We have a huge number of downloads that we have to serve up and ensure that they remain in the right place and don't get broken. We have over 200 dedicated machines endlessly churning out these binaries every night. And we have I think it's over 106 GitHub repositories now that all need to be patched and have security vulnerabilities that need to be resolved. So moving into the build and binary section of this deck, I wanted to quickly walk everyone through an example build test pipeline. So the way that we currently work today, we have a Jenkins farm, which I'll cover in a minute. When we kick off a build pipeline, we firstly get the OpenJDK source. That can come from Mercurial, that can come from a vendor such as OpenJ9 or Amazon Corretto. or it can come from our internal GitHub mirrors. We then pick a branch. If we have a set of changes, we pick our dev branch. Otherwise, we default to master. And then that gets loaded into a build environment. As long as the build passes, it then gets put into our test environment. And then as long as all our tests are good, or we have a very small set of triaged failures, we deploy. And as soon as we deploy, that's available on our website, our API, any other place you get it, Docker Hub, whatever it is. And the really interesting thing here is the red dotted line, which is the approved third-party OpenJDK binaries, which is quite a new concept to us. If people haven't already seen, Red Hat recently started adding their Upstream binaries to our website, which are basically their reference implementation build of OpenJDK vanilla. And so they build it internally, and then they bring it out to our public build farm, and they put it through our test pipeline to ensure it passes, and then they deploy it in the exact same way as before. As I mentioned earlier, we have a Jenkins pipeline. Our Jenkins build farm is completely public. Anybody can go and view what's going on there. To kind of summarize what we have a build folder for every version, whether that's JDK 8, 9, 10, 11, 12. And then we have a job for every OS architecture combination. So Linux x64, Linux ARM 64, whatever it is. I must admit here, we don't always have green builds. I did tactically pick a green section of the farm. We've always got build failures, and we've always got test failures that we need to triage. So in terms of the VMs that we support today, we support Hotspot, which is the one that I imagine everyone here is mostly familiar with. You may not know what it is, but it is always there in OpenJDK. If you've used Oracle's JDK in the past, you used Hotspot's JVM. It's basically the VM that's most widely used today, and it's suitable for all workloads. So if you have a Java app, or you're downloading something that requires Java, Hotspot is a guaranteed way of ensuring it will run. Anybody that builds a Java app builds it to work with Hotspot. As an ex-IBMer, I do unfortunately have to mention Eclipse OpenJ9, which is an alternate VM to Hotspot. It can be very good. It can make no difference. So it's worth downloading and trying it out. Essentially what they do with OpenJ9 is rip out the Hotspot code from the OpenJDK class libraries and inject their own OpenJ9 VM. And I'm told, at least, that in certain cloud and container workloads, it can be more efficient. It has a lower memory footprint. So I mentioned earlier, we have a pretty broad set of supported platforms. This includes all the obvious ones like Windows, Linux, Mac. It also includes interesting stuff like IBM mainframes, Oracle Spark, Solaris, AIX, and even RISC-V, which is about the most bleeding edge we can be, which is the open source architecture chipset. And we've already got some machines running. I don't know if anyone can see them behind me. There are some RISC-V development boards that are churning out builds for us today as an early access OpenJ9 build. So when we kick off our builds, all of the sources are based on OpenJDK. As I mentioned earlier, we mirror those Mercurial repositories into our AdoptOpenJDK GitHub, mainly because we prefer Git to Mercurial. In recent time, now that Scala has kicked off, we may consider moving that back towards the official Oracle repos. And we provide no additional functionality. So don't please come asking us to add a new GC, for example. We are not set up to do that or support it. We do, however, have some additional build steps and patches, like the notarization, horrible notarization requirements that went in for Mac OS. If you don't know what notarization for Mac OS is, you're very lucky because it's an absolute pain. So I think I'm now going to hand back over to Hendrik to talk a little bit about test. Is that right? Yeah.
Yeah, maybe we can do the last question now.
I love these questions.
Before that, because I think that just works very good now, because this is about security fixes, right?
That's the last one I have.
Yep, perfect. That's right.
That's a good one. I like
Okay, let's give everyone a few more seconds.
What security fixes?
And here's the result.
Okay.
Oh.
Okay.
So it's, yeah, half of the people. Yeah, but that's I think that's normal. And so at least some of the people are not lying. And yeah, I mean, to be true, I have so many different JDKs on my local machine. A lot of them are not updated too, because I have an Amazon Coretto, I have a Bellsoft, I have an Azure one, I have several from Adopt, I have some from Oracle. Some of them are just not updated, so I can totally understand it. But this is one special point that is interesting when talking about tests, because so based on what we've seen so far is that since at AdoptOpenJDK, all the infrastructure and build scripts that you need to build an OpenJDK or Java binary for any platform like Windows, Mac, Linux, and so on, is completely open source, and you can even go into our Jenkins and just copy the steps that are executed there. You can easily just do it on your own. So you can do a homebrew OpenJDK build if you want. And just check out the latest state of the OpenJDK binaries. I mean, then you are sources, then you are even newer than the last release, because there is not a daily release of Java. Maybe you have even more security fixes than the last release, and then you can build it. The problem is that you cannot sure that this really works. Maybe you did something wrong in the build. Maybe the last person who committed something to the OpenJDK committed a horrible bug. I mean, we're all developers, right? Every one of us has already did something like that, just committing something that breaks the whole project. And one thing that is important for us next to having all the things in the open are the tests. So what do you think? Maybe you can write something in the chat. What do you think, how many tests are needed, or how many tests are we at AdoptOpenJDK execute to check that our binaries are enterprise ready with a high quality and secure? Any idea how many tests we are running? So anyone will put something into the chat? 4,000 tests. Okay, Holger says 4,000 tests. So anybody says more or less tests? Somebody? Okay, Carsten says 70,000 tests. Okay, so maybe a certain number, and then we will continue here. 1, perfect. Who's that? Hendrik? Huh? I haven't done. This is Aya George. You are logged in with my name, right?
Hendrik, why did you say 1?
I was like, whoa, what's that? Hendrik Ebbers says what? I haven't done anything. Okay, good. That was you. Anyway, okay. Yeah, that much better. Okay, 1,000. So we have something like 4,000, 50,000, and 100,000. So let's have a look. So first of all, what we have in AdoptOpenJDK is, like in all other parts, we have everything open. And to just test Java binaries and Java builds, we have a test suite that is called Aqua. And this is a test suite that is just there to really test Java binaries. The whole suite is open source, and it was contributed initially by IBM. It was part of this Get OpenJDK from IBM initially, and they contributed it to AdoptOpenJDK already with a lot of tests. And this test suite just grow and grow and grow growed a lot in the last years. And today contains a lot of open source tests that are executed to just check our OpenJDK based builds and even other OpenJDK based builds, as we will see. So let's have a look at our tests. As George mentioned, we build Java for a lot of platforms. So we have Windows, Mac, Linux, Can you go to the next slide, George? Thank you.
Yeah, sorry.
And next to this, we can provide hotspot-based JVM, or we can provide OpenJ9-based JVM. For OpenJ9, we have two different versions, a regular one and one with a large heap. This means that currently we build binaries for 58 different platforms. And here we do not only provide one binary like Java 8, we provide binaries for Java 8, Java 11, and to be true, this slide is outdated too, because now we already have 15, so it's Java 14 and 15, I think, that we are building. We build the master, and we even build some feature branches for Java. We, for example, currently provide builds for Project Valhalla. And yeah, at the moment we provide 6 different, or builds of 6 different, let's call it, branches out of the OpenJDK. And in our test suite, we have 250,000 tests. So it's not 1, it's not 4,000, it's 250,000 tests. But what we are doing is we are building for all these platforms, all these different versions in our nightly and for each release. And this means that in each nightly at the AdoptOpenJDK build farm, we execute about 87 million tests in a nightly. That's a huge number of tests. And you can think that we cannot execute these tests like one after each other. We need to do some async or parallel execution of tests, and things here need to do a lot on cloud machines in parallel and so on, because otherwise it wouldn't be a nightly, it would be a monthly or something like that if you execute like over 80 million tests one after each other. So what these tests are all about, as already mentioned, we have this Aqua test suite, and this Aqua test suite groups all this test into different groups. Here we can see those groups that are part of our test step, that is part of each build, right after building the JDK binaries, and before deploying them, we just test them. And all those tests are part of one specific group. In general, we have 6 different groups: the OpenJDK, the functional, the system, the external, the perf, and the JCK group. And the Aqua test suite is designed that all of these groups can be executed in parallel. So for each Java binary can be executed in parallel, and next to this, for each binary, we can split up the test one into 6 parallel ones, because each group can be executed in parallel. So let's have a look at those groups and what is in those groups. So the first one, the OpenJDK group, just contains tests that are part of the OpenJDK, that are part of the basic Java repository. These are not much tests. This means if you check out the OpenJDK, build it, and really run all tests that are part of the OpenJDK, you only execute about 6,000 tests. So who was it? Holger, your 4,000 tests were in general right. If you're a Java vendor who built Java but do not take care about testing that much. To be true, for a lot of the vendors that provide Java, you just cannot say how much testing they do because they don't do it in the open. Maybe it's just the 6,000, but I won't say that because I just don't know it. The functional and system group contains all the tests that were contributed by IBM, and these just contain functional tests for the functionality of a binary, and system tests, so testing a lot of native stuff, integration into the system, and so on of the Java binary. The next group is quite interesting, which is the external group. As you can see, this contains a lot of tests, 125,000 test cases. And here the cool part is that we have not created those test cases because here we reuse other tests. For the external group, and as example, all tests of the Apache Tomcat project will be executed here. All tests, unit tests, integration tests, and so on of DerbyDB will be executed here, for example, to test our Java binaries. If all these tests run perfectly with those Java binaries, we execute TCK, that stands for Test Compatibility Kits, for 5 specifications of the Eclipse micro profile, and run all those tests that are part of the TCK on top of our binaries to check our binaries. We will see an example of those tests later. The perf group contains benchmarks. This can be used to just check that the Java binary you are testing is as performant as you want it to be. How many tests I like assert true is the question from Sasha. So to be true, I've never looked into the 125,000 test cases that we import from external framework and libraries, but I don't think that you find such a test in, or that you find a lot of such tests in, for example, Apache Tomcat, DerbyDB, or the Eclipse micro profile. The last group is the JCK. And this can be used to execute the Oracle TCK against the binary. The Oracle TCK is a closed source and commercial test compatibility kit that can be bought from Oracle, or that you can get a license from Oracle to use it to run your binaries against these tests. While for AdoptOpenJDK, as a community, this is at the moment not possible. But it will be possible for Eclipse Adoptium. So once we are an Eclipse project, this will be done too. But the Aqua Suite already have the possibility to do this since the beginning. And other companies, we know that Java vendors use the Aqua Suite to test their Java binaries. They already use this group internally to execute it against their licensed TCK test from Oracle. Okay, as said, we will have a look at an external test, how this looks like. So you can think about it like this. A lot of the tests will be executed in Docker containers, which means like so here we see an example for the Derby tests. So to do so, a Docker container will be set up and started. And the JDK binary that we've just built and that we want to test will be copied into this Docker container. Afterwards, we install some build tools like we need Git, we need Maven, and so on. And then we will check out Derby, the Derby sources from the Derby repository. I don't know if Derby is at Git. Let's assume Derby is at Git. So we just check out the Derby resources from Git with a specific tag. Normally, this is the last release of the tool, will be updated from time to time. Then we build the tool, in this case Derby, and once this is done, we just run all the Derby unit tests. If Derby is a Maven project, I don't know if it's true for Derby, you can assume that we really just do a Maven test here, for example, which will then use internally our Java binary to execute all the Derby tests and see if they are running. I mean, the tests are running. This is a stable tag from Derby. We know that those tests are running. If they are not running based on our binary, we know that we have a problem with our binary. The positive thing is that Derby is already built with our binary. So we even do not only have the Derby tests here, we even check if we can build Derby based and compile Derby based on our binary. So this is a lot of things that are tested here automatically. And what Aqua does is, it collects all this information and make test results out of it. And yeah, as we've seen, we have like 125,000 tests that are executed here. So at the end, Aqua will just merge and reduce all these tests together. So at the end, we just see a red or a green button, dot, whatever, and can see if our binary that we have tested is working or if we have a problem somewhere. So these about the tests, and I hope this shows to you how important it is to test Java binaries and how interesting it is to really do it in the open and see how much one company or one vendor does to really provide stable Java binaries. We have already now seen 3 different projects that are hosted at AdoptOpenJDK. First of all, the Java binaries. Then we've seen the build with all the build scripts and so on that are just a repository in our Git repository. And we've seen the Aqua test suite with all the tests. Next to this, AdoptOpenJDK even hosts some additional projects. Yeah, some we've already talked about here on the slide, but some are quite new. Let's just have a short look at all of them because, yeah, we are already talking more than an hour. So IST-Web is an open source replacement for WebStart. So if you are using WebStart, we have an open source solution for you, which is called IST-Web, that is bundled into AdoptOpenJDK 8 for Windows. So when installing AdoptOpenJDK 8 for Windows, in the installer, you can check that you want to have IST-Web installed locally. And this provides a Java WS executable so that you can run JNAP applications. Next to this is the base of the open source tool OpenWebStart that more or less does the same, but provides a lot of more native functionalities and work with any JDK from any vendor and provides Java 11 functionalities too. JITwatch is a tool that you can use to analyze a hotspot JVM. So you can analyze the just-in-time compilation on this JVM and just visualize the output. JLink Online is a tool that you can use. So JLink, let's start with JLink. JLink is an executable that was introduced in Java 9 and that let you build a modularized Java version that just is made for your needs. So let's assume you have an application that that don't have an UI, you only work with this application on the shell, and this application does nothing but accessing a database. So you don't know Swing, you don't need Swing, for example, for this application. You need all the things that are part of Java Lang, all the base functionalities, and maybe the things that are part of Java SQL. So with JLink, you can create a Java runtime that is much, much smaller than a JDK or JRE because it really then only contains the modules that you are needing for your application. What JLink Online is a service that we provide at the end. It's a REST endpoint that you can call and as parameter, you can give an array of modules that you need, an operation system, a Java version, and so on. And this REST endpoint, or on the server side, we will build a Java binary that exactly contains those modules for you and return it. This is quite interesting if you're, for example, running applications in Docker containers and you want to have those Docker containers very, very small. Then in the initialization of the images, you can just call a JLink endpoint to create an up-to-date with all security fixes Java version for you that only contains the modules that you need. Jdk Mission Control, we've already mentioned this. This is the analyze support tool that was originally coming from Oracle that is now part of the OpenJDK, and we even host the binary, so we don't host the sources. This was contributed to OpenJDK, but we build it and we provide the binaries on our website. Aqua, that is a test suite we already talked about. And the last point is quite interesting because, so as said, what Red Hat does is they do all the work in the OpenJDK, in the open, and maintain the Java 11 and 8 branches. And based on this, they do builds. So they create OpenJDK binaries. These binaries are even TCK tested and so on and so on. But what Red Hat is not doing is providing them on redhat.org or something like that for download. All these Red Hats are uploaded to AdoptOpenJDK are executed against the Aqua test suite to test again that they are just working fine, and then uploaded to our, I don't actually know where they are. Are they on GitHub, George, or where are they uploaded to? Yeah, they are uploaded.
They get pushed to GitHub binaries.
Yeah, they push to GitHub, and we provide them on our webpage for downloads. So these are just some other projects that we have. And okay, let's make it fast and go to the next slide. Let's talk about the technical roadmap that we have. So some features where we are currently working on that we want to provide in future, and some of them are already there in the first version. So something that I want to show you is the API, because this is quite useful when you want to get a Java version. And here I want to show a small sample demo, because I don't want to have only slides in this presentation. Let's do at least a minimum hands-on, even if this is hard for a topic like this. Okay, maybe I start here. So since a lot of you use AdoptOpenJDK, I think I don't need to show you the AdoptOpenJDK page at all. I assume you know it, where you can download for Java 8, 11, currently 14, and you can choose between Hotspot and OpenJDK and then just download it or click on other platforms and get a huge list of Java binaries where you can choose from. Next to this, you can download the OpenJDK Upstream binaries that I just mentioned 2 minutes ago that are built by Red Hat. As mentioned earlier, we have about 180 million downloads now. We have even that one is in the open, our download stats, where you can have a look. And here you see more or less what we've seen in the questionnaire, right? Java 8 is getting better and better, but Java 11 is getting better and better, but Java 8 is still the version that is used the most. And here you can even go inside and have a look at the versions. This is the newest one, 11.8. As you can see, the most used version is still 11.03, but this is the current version. And here you can see, I don't know, the operation system. Here we have Linux, here we have, for example, Windows, and so on. Anyway, next to this, George just showed it on a slide, but I want to give you a view of our Docker, just to have an idea, not Docker, Jenkins, just to have an idea how many build jobs are part of AdoptOpenJDK to build the Java binaries. If you are interested to contribute, we will talk about that later. You can find us at GitHub at github.com/AdoptOpenJDK. So one new feature that I want to show you is our API. And the API is a REST API. What we are seeing here is Swagger. If you don't know Swagger, this is a front end for REST endpoints where you can see a documentation of the REST endpoints and just try them out. And what we provide, for example, are REST endpoints to get Java binaries. So when having a look at this endpoint, you can already see that here in the URL, there are a lot of parameters that you can specify. So let's just try it out. Let's say I want a 64-bit Java binary. I want Java 11. I want normal heap size. I don't want a JIE. I want a full JDK, and I don't want OpenJ9. I want hotspot. I'm currently on a Mac, and I don't want early access. I want a general availability release. Here I can, at the moment, choose if I want to download AdoptOpenJDK-based binaries or OpenJDK. Those are the vanilla OpenJDK binaries that are contributed by Red Hat. And now I can execute it. To be true, now in the response, I get an error because he now says, hey, you want to download something, I forbid this. This is just a security thing in this front end. But here we see how the URL would look like. And if I just copy this URL and type it here, I don't know what happened earlier. Now you can see that this is downloaded, right? Yeah, I want to download something from this page. And now I'm just downloading the most updated Java 11 binary for Mac OS. Yeah, that's quite cool. And next to this API, we have some other things we're currently working on. And George will give an overview here.
Hendrik, can I interrupt you for a second? We have a few questions in the chat. Maybe we can just have a look at that.
Absolutely.
So Carsten was asking on how many machines are in the build cluster. Do you have an estimate for that, or like a rough number?
For the main Jenkins build farm, I think I mentioned earlier, there's over 200, but we're trying to move away from having static machines. That's actually the next item that we'll cover here.
Okay, and then there was another question by Sasha, who was asking if you allow introspection of the object model within the GraphQL API.
I have no idea.
Yeah,
Okay.
Unfortunately, I'm the same on that one. I'm not too sure.
Yeah, I mean, we can, so this is a point that, as said, Adopt is becoming quite big. So when having a look at our GitHub organization, you see that we already have a lot of committers in the organization. And based on this, yeah, there are things like, for example, the GraphQL endpoints where I have absolutely no idea how they are working. But we have a Slack at AdoptOpenJDK, and there's a channel for the API endpoints. And that would be a good question to ask there. And I assume they even do something like weekly things like that, where people from the TCK, for example, attend. So this is an example how we are working, right? We have the TCK, we have meetings each week where we discuss open points, but all the other groups, like the build group, like the test group, and so on, are groups on their own, where normally people from the TCK are leaders of the group or just part of the group, and then have all the knowledge of this specific area and bring it into the TCK. Okay.
TSC.
Not TCK. Yeah, you're right.
Yeah, get off.
Into the steering committee, not into the test compatibility kit.
Yes. Cool. Okay then. Thanks for that demo, Hendrik. So moving on. So as promised, the next kind of thing in the roadmap right now is dynamic infrastructure. And what I mean by that, as I mentioned a second ago, we have over 200 machines that are constantly spinning, and we're constantly paying for them, or they're sitting on people's desks or whatever the setup is. And what basically happens is we trigger a job, Jenkins selects an executor, and it goes off and runs its build and test. And this is great. We always have sort of executors sitting there ready to go, but we have to patch all of these machines all the time. There's a whole load of security issues with having dedicated machines running, particularly with public IPs. And so we want to move away from this. And so what we're trying to work towards is a setup more like this. And what this looks like is we trigger a job, and a cloud provider, it can be any cloud provider, not even just the logos that are included here. The only requirement is it can give us a Linux distribution with Docker pre-installed, or allows us to override the build config. And then what happens is we have a Docker file that contains all of our build dependencies that we regularly build and patch. And it just basically pulls down that Docker file, it inspects it and runs inside it, spawns a bash shell, and then kicks off the build as it would before. And there's some really kind of useful benefits to this setup. Before I get into those, I always like showing people my favorite meme about Docker, because everyone likes a meme. So, right, parallelization. So yeah, the key thing here is if we can dynamically spin up machines for, let's say, 10, 15, 20 minutes at a time, rather than paying for one machine 24/7 every single day of the year, we can spin up 100 of those machines all at the same time and very quickly run all of those tests that Hendrik was mentioning earlier. And so we can get our test results back that bit faster, which is really, really beneficial to us. it also means that when we come to testing pull requests and code changes, we can get answers back a lot quicker by having all of these machines spinning up at the same time. So we never have executors waiting to be made available. We never have any of the issues we used to. We just basically carry on as we would, but using Docker files. This obviously has its limitations for platforms that don't support Docker, such as Mac OS and so forth, but this is certainly a good step in the right direction for improving the infrastructure story. We do have a few other items on the roadmap I won't sort of specifically go into. We're doing a website redesign because the website was written by myself on a plane in handlebars and it's pretty poor. As Hendrik mentioned earlier, we have the J-Link Online project, which is pretty new to us. Pardon me. So that's quite an exciting one for us to kind of delve into further. And we're also doing a whole lot of work with GitHub Actions and the GitHub team. I'm not sure if people saw the other day, but as of, I think about a week ago, AdoptOpenJDK is now the default OpenJDK binary on a GitHub executor environment, which is pretty cool. Now, we've been talking for about an hour and a half now, so I appreciate everyone bearing in mind and listening. At this point, I always like to say a massive thank you to our sponsors. We really couldn't run successfully at the scale that we're at now without the help from every single one of these people, whether that's infrastructure resources that we're getting from them or even personnel. If people are interested in sponsoring the project, you can get in touch with myself or Hendrik, or even you can email directly to sponsorship@adoptopenjdk.net. We like this slide here. We've got a growing community all the time, and we'd like to think that the skills that some of you on the call may have may be a good fit for the project. And if you've got a spare hour or two here and there that you'd want to contribute back to the Java ecosystem, then we hope that you consider us, and we hope that we can see you all soon. Next slide has some information on how to actually get involved. Here you go. There's a GitHub and a Slack link as promised. So I think we're there. We are there. So any further questions? I did see something pop up in the chat. I'm not sure.
Yeah, there was one question about the, I don't know how to spell it, Gyro of the Eclipse Foundation. This is the build platform that they have. I think we already did discussions about that in the meetings. So these are things where we currently just working on together with the Eclipse Foundation to prepare the move of AdoptOpenJDK into the Eclipse Foundation. And this is just one point of the things we currently work on, how to handle the infrastructure, where to move the infrastructure. To be true, the hardest part at the moment is the naming, as always. But yeah, infrastructure is another important part where we're currently working on. So I cannot say if it will be running or if this will be used to run some of the jobs, but it's in discussion at the moment. Another interesting thing maybe, so if you have any questions, just raise your hand or ask questions in the chat. George and I are, will answer any of your questions. Maybe some additional words about the contribution. So a project like this is huge, and normally as a Java developer, you think I have absolutely no idea how Java is built, and this is way, way, way too complex for me. And this is a project where I just cannot contribute because I have no idea about that. I'm not good enough. And this is just not true, because, so let me tell you how I started to contribute to AdoptOpenJDK. The first thing that I did at AdoptOpenJDK is that I did the German translation for the web page. And please do not check the web page in German today, because there are so many changes on the web page that all the phrases are broken and it just looks weird and horrible. So this is something where we, for example, need help. Is there somebody who is willing to do a German translation of the website is more than welcome. Next to this, we definitely need help in a lot of documentation tasks. We're currently working to define good first issues, to define documentations for good first issues, to be part of the Hacktoberfest maybe this year with some issues that are really very good starters to get not only into open source development, but into AdoptOpenJDK and OpenJDK too. So don't be afraid. And if you have any questions, you can always just ask me, ping me on Twitter, even in German, totally fine.